The last section that we are going to be talking about in this entire course is vectors. Vectors are definitely going to show up in physics, so make sure you understand these concepts. A vector is a specific quantity drawn as a line segment with an arrowhead at one end. Don't get this confused with array. Array is also kind of looks like that, a line segment with an arrowhead at the end, but array goes on forever. A vector actually ends where its arrowhead ends. A vector has an initial point where the vector starts. That's where the arrowhead is not. In this case, right here, it's at the origin. It may not necessarily always be at the origin. The terminal point is where the arrowhead is. That's where it ends. A vector is defined by its magnitude, which is its length, and its direction, which is where the arrow is pointed. Thus, a vector is a directed straight line segment. It has the initial point at 0, 0 and a terminal point at AB. Notice that AB are in these little arrowhead brackets. That's telling us that it's the end of a vector. In your homework assignment, it's going to require that you use these arrowhead brackets. You should just be able to use the greater than and less than keys on your keyboard. If you hit shift comma or shift period, that should work for you. If you have any issues with that, please reach out to your instructor and let them know. The magnitude and direction of a vector. Given a position vector AB, the magnitude is found by the square root of a squared plus b squared. Isn't that familiar? So the magnitude is found using the Pythagorean theorem. The direction is equal to the angle formed with the x-axis or with the y-axis depending on the application. For a position vector, direction is found by tangent of theta, so the direction that it's going is going to be that theta equals b over a. Or inverse tangent of b over a gives us theta. Two vectors, v and u, are considered equal if they have the same magnitude and same direction. Additionally, if both vectors have the same position vector, then they are actually equal. Find the magnitude and direction of the vector with initial point negative 8, 1 and terminal point negative 2, negative 5. Draw the vector. All right, let's actually start by drawing the vector. That'll probably be a bit easier. So here's our coordinate plane. X is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Y is 1. So that's its initial point right here. Initial point. And terminal point is at negative 2, negative 5. 1, 2, 3, 4, 5. Negative 2, negative 5. That's where our arrow is. So our vector is going to go, oh, come on. Right. Whoop. I cannot, for the life of me, draw with this. I gotta use my mouse. Can't draw with my mouse either, apparently. Try this. There we go. Good enough. So this is point negative 8, 1. This is point negative 2, negative 5. So we have to figure out what this angle is. We have to figure out what the magnitude is. So what is the magnitude? We have to figure out what this would be if we were putting this into standard position. So it looks like we went over 1, 2, 3, 4, 5, 6, and down 6, right? So if we move this over to initial position, we'll go over 6, down 6. And it would be like right there. I don't know why I could braid it so easily there, but not on the other side. So all I did was shift this vector over and put it into standard position. The length is still the same. The direction is still the same. I simply moved it. I used that property where two vectors, v and u, are considered equal if they have the same magnitude and same direction. So these two vectors are equal. We have to figure out their magnitude and direction. I feel it's going to be easier to figure it out in standard position. So this is at 6, -6. The angle is moving this direction. We always go counterclockwise. So how do we figure out this length? Well, we went over 6, we went down 6. So we have 6 and 6. We went down 6, we went to the right 6. So let's use what we have here. We can do a squared plus b squared and take the square root. So 6 squared plus -6 squared. And we can take the square root and get our magnitude. Essentially, what is the strength of the vector? We get 36 plus 36. M equals, we can factor out a 6, or we can factor out a 36 and get 6 times the square root of 2. That is our magnitude. How about our direction? We can use this inverse tangent formula. Inverse tangent, I don't know why I'm writing an S. I'm all about sine. Tangent to the -1 of b over a And remember, when we were talking about these vectors, a is x, b is y. So b is going to be -6 over 6, which is the inverse tangent, tan -1 of -1. What is the inverse tangent of -1? If you don't want to figure it out in your brain, you can use your calculator. There's actually going to be two inverse tangents. It's -45 degrees. So -45 degrees, what if we wanted that positive? Well, we simply add 360 degrees, and that tells us that it is 315 degrees. Those two are equivalent angles. They mean the same thing. All right, show a vector v with initial points at 5, -3, and terminal point at -1, 2 is equal to the vector u with the initial point -1, -3, and terminal point -7, 2. We will draw the vectors. Let's do this thing. So the initial point is at 5, -3. So 1, 2, 3, 4, 5, -3. 2, 3. That's where the initial point is. Terminal point is at -1, 2. -1 up 2. That's our terminal point. Let's see if I can draw that. Close enough. So that's our first vector. Initial point at 5, -3. Terminal point at -1, 2. Let's draw our other vector. Its initial point is at -1, -3. And its terminal point is at -7, 2. So 1, 2, 3, 4, 5, 6, 7, up 2. So this one is at -1, -3, -7, 2. Well, we can see that we just moved these over 6 places. The difference between 5 and -1 is 6 places. Same thing with the top. The difference between -1 and -7 is 6 places. So their length should be the same, their magnitude should be the same, their direction should be the same. So just reasoning it out, these two are equivalent vectors. All right, let's calculate the component form of a vector. Given vector xy with direction angle theta, magnitude is expressed as square root of a squared plus b squared, like we mentioned before. Cosine of theta is equal to m cosine of theta, x is equal to m cosine theta, y is equal to m sine of theta. So let's reason this out. The x and y components are to be seen as the adjacent and opposite sides to a 35-degree angle. So just as an example, we have a 35-degree angle, the opposite side, the hypotenuse, and the adjacent side. So we know this is the blue portion here is the vector itself. We are trying to figure out what x and y are here. So when we do that, we know 35 degrees, we know the hypotenuse. So what two trig figures do we use when we know the hypotenuse? Cosine and sine. Sine will give us opposite, cosine will give us adjacent. Adjacent is our x component, so that's why we use cosine. Y is our opposite component, and that's why we use sine. So let's do this. We have our f, so cosine, cosine of 35 degrees equals x over the hypotenuse. Multiply both sides, 3/16 times cosine of 35 degrees. Put that into your calculator. Times 3/16 gives us 258.9. And how about our y value? Then we will use sine of 35 degrees equals y over 3/16. Multiply both sides. So what is that going to give us? 35 sine times 3/16 equals 181.25. Well, let's call it 181.3. So those are our x and y components. So essentially, we're just using trigonometry, hence the reason vectors are in trig, to find our x and y components. Let's find the x and y components of a vector with length 7 at angle 135 degrees. So, drawing this out, 135 degrees is going to be about right here. Length 7. We have to figure out what our x and y are. So we're going to make a triangle. What is this angle right here? Oh, come on. This angle right here. It's going to be 180 degrees minus 135, which is 45 degrees. So our internal angle here inside our triangle is 45 degrees. Our hypotenuse is 7. So let's see what we can do. Cosine of 45 degrees equals x, our adjacent to the angle, over 7. 7 times cosine of 45 degrees equals x. So x equals about 4.9. Now we have to use logic here. On our xy axis, we are to the left of the y-axis, which means our x is in negative territory. This x is negative. How about finding our y? Sine of 45 degrees equals y over 7. 7 times sine of 45 degrees equals y. So y is equal to 4.9 as well. However, y is going up, so y is positive. Our x is negative, and our y is positive, and that is our answer. Go ahead, take a moment and see if you can figure out the solution to problem 14. Reach out if you need any assistance.